Hi and welcome back. In this video we're looking at some advanced set operations, and they're not going to take very long. There's just a couple of them that I think you should know about. Let's create a set that I'm going to call set 1, and this is going to be 1, 2, 3, 4, 5, and then a set 2 that's going to be 1, 3, 5, 7, 9, and 11. A set is a collection of unique and unordered elements. Therefore, what really matters is which elements are in the set. It doesn't matter if the 1 is at the beginning, because this is unordered, so really we cannot get that. What matters is the 1 is there, the 1 is there. The 2 is in set 1, but there is no 2 in set 2. That's really what matters, which elements are in the set. For example, you may have a set of lottery numbers that you have played, and you may have a set of the winning lottery numbers. And you may want to see which numbers are in which. So let's imagine set 1 is your lottery numbers, and set 2 is the winning numbers. So you've obviously earned quite a lot of money because there are quite a few numbers there that are the same, 3 numbers. So how would we check if these numbers match? Well, we can print your lottery numbers dot intersection winning numbers. This should be numbers. And I'm going to comment out this other print statement there because we don't need it just now. So we're printing something a bit larger here. Your lottery numbers is this first set. And we're going to say dot intersection, and that's another method that is going to take in the other set inside the brackets. So if you've ever done maths, you'll know what an intersection is. But if not, let's just look at what comes out. And we can run this again. I'm actually going to clear it first and run it again. What do you think is going to come out with the intersection of these two sets? We get another set. So this evidently produces a set, and that's the output. And the set contains 1, 3, and 5, which, as we know, are the numbers that are in the first set and also in the second set. So this calculates the numbers that are in both sets. Okay? We can also do print your lottery numbers dot union winning numbers. What do you think the union will print? If you've done maths, this is an easy question. But if not, I'll give you a wee hint. Union is going to essentially add the sets together. So our first set has 5 elements. Our second set has 7 elements. A quick question for you. Would you expect the set that gets printed out to have 5 plus 7, 12 elements? Would you expect the set that gets printed out to have 12 elements? Hopefully you said no, because this set, as you can see, only has 9 elements. 9, 10, 6, 8. 8 elements, that's right. Evidently I can't see very well. Or rather count. So the union is the 1, 2, 3, 4, and 5. That's the first set, the set here. And we are uniting that set with this other set. So we do 1, 2, 3, 4, 5, and we add the 1 to it. But 1's already there, so we discard that. Then we add 3, but 3's already there, so we discard that. Then we add 5, but 5's already there, so we discard that. And then we add 7, 9, and 11, so we end up with 8 elements. 1, 2, 3, 4, 5, 7, 9, and 11. Remember, there are no duplicates in sets. Every element has to be unique, so that's why 1, 3, and 5 never appear. Finally, we can also do print something like 1, 2, 3, 4 dot difference 1 and 2. And that should be like that. It doesn't matter in Python. You can have them like this if you prefer. But I like my code to look a specific way, sadly. So there we go. Okay, what do you think this we're going to print out? 1, 2, 3, 4, difference. So what is the difference between these two sets? The difference between the two sets is 3 and 4. That's the numbers that are different, and then we get 3 and 4 back. So these 3 set operations are really useful in some cases, and just not very useful at all the majority of the time. However, if you know about these, there will be a moment in time where you will realize that this is the perfect solution for something you want to do, and then you'll know that this exists. And most of the time you won't use them at all, but nevertheless, they are there, and if, for example, you want to calculate lottery numbers, maybe you will, then this is perfect, the perfect tool, really. If you ever want to deal with unique and unordered things, then this is also a perfect tool. So that's it for this video. Hope you learned something here, and I'll see you in the very next one.